Hi, Assalamualaikum. My name is Nur Hazirah binti Hamzah. Today, I would like to explain about an investigation of the bridge response due to the lateral load at White Bridge Pier. A scour refers to a situation where the bridge substructure is frequently exposed or the riverbed elevation is reduced due to erosion caused by water. White piers are defined as piers that are equal to or wider than 10 feet, which is 3 meters, and have a pier width to sediment diameter ratio greater than 100. The failure caused by scour are mainly a result of the loss of soil support for the foundation and the deterioration of foundation element, leading to a decrease in foundation capacity. Scouring incidents have occurred near multiple bridges in Kedah, Pahang, Sabah, Kelantan, Perak, and Selangor in Malaysia. Problem statement. First, the occurrence of major flood that often occur during the northeast monsoon in one of the causes of the collapse of the bridges. Second, a lack of research on the effect of lateral load on the pile using numerical analysis for what bridge pier is still limited. Third, there are few studies on predicting the semi-empirical equation of the lateral load capacity for white piers. They have two objectives, which is to determine the scour effect at White Bridge Pier on laterally loaded pile in different types of scour. Next, to evaluate and validate the result with current existing equation for predicting lateral load capacity of the white piers with multiple scour depth and lateral load by using two different types of scour, which is global and local. Next, we go to the flow chart. First of all, determination of the bridge pier properties. Next, determination of soil properties. After that, determination of parameter analysis. Then, development of 2D numerical model using basis 2D. And we proceed to data analysis with three cases, which is the effect of the bridge response on lateral displacement, effect of bridge response on bending moment, and the effect of lateral displacement on different lateral load capacity. All these cases will be performed in the two different types of scour, which is global and local scour. Next, we proceed to validation of the result with the previous study equation. And last but not least is conclusion and recommendation. Next, for the methodologies, first of all, we would like to define the soil and the pier properties. Next, create the soil, pier, and the scour area in the places 2D. So, at the soil model, we have to insert the lateral load and the interface. Next, we go to the stage construction. We must activate all the elements that we want to run in the simulation. Then, we run the simulation and get a match of two definite element analysis. Then, for the total displacement and the bending moment of the pier, we have to double click the pier in the places 2D to get the effect of the pier. Okay, next we study the effect of the bridge response on the lateral displacement. For the local scour with 1,500 kN, the lateral displacement will be increased to 5.58%, while for the global scour, it will be increased to 11.27%. So, we can conclude that the graph indicates that as the scour depth increases, the maximum total displacement of the pile also increases. Next, we study the effect of the bridge response on the bending moment. For local scour with 1,500 kN, the maximum bending moment along the pile length increases by 8.46%, while for the global scour, it will be increased by 13.05%. So, we can conclude that the chart illustrates that as the scour depth increases, the location of the maximum bending moment shifts to a deeper depth. Next, we study about the effect of the lateral displacement on different lateral load. So, as we can see, the diagram shows that when the lateral rises, the pile's lateral displacement rises as well for local scour and global scour. Okay, next, the validation of the equation. So, as you can see, that's the simplified model equation that I get in this study. Okay, when I compare to the previous study, the equation are approximate to the previous study. For the conclusion, I can conclude that the scour type significantly affect bilateral capacity, with a local scour causing a 21.71% decreases and a global scour causing a 10.78% decreases. The semi-empirical scour weakening formulas were developed based on the numerical result, considering the different effect of the two scour types, which is local and global scour. The scour type was identified as the main influencing factor in bilateral capacity, and appropriate design consideration and countermeasures are necessary to minimize a scour effect and ensure bridge stability.